A wall of fire tears through the night. The ground splits open, and from the darkness, a torrent of molten rock shoots 200 meters into the sky. Air turns toxic in seconds, sirens wail, but for some, the warning comes too late. This is not a simulation. Scientists say it's imminent, and the data shows it could happen at any moment. Let's rewind. Forget everything you think you know about volcanic eruptions. Forget about those slow-moving lava flows that you can easily outrun. What's brewing beneath Reykjanes black rock isn't merely a normal eruption, but rather, it's a profound systemic failure. February 2026. High above the peninsula, the sky is a deep, dark violet, and the wind howls over a landscape that truly resembles the moon's surface more than Earth's. For months, the world thought the fire was out. After the August 2025 eruption, silence fell. Tourists returned to the Blue Lagoon, barricades fell. Life returned to normal, but beneath the surface, the unimaginable was happening. Deep in Earth's crust, GPS sensors vibrated. They vibrated at a frequency geologists had never seen. This silence wasn't a recovery. It was a chokehold. The Earth held its breath, accumulating a magma quantity so massive it threatens to rewrite the geography of this nation. Picture a paradise, nestled right atop a ticking time bomb. 5 kilometers deep, pressure builds to a breaking point, defying all computer models. The headline is simple, but it will haunt you. Iceland's reservoir is overfull. In the next few minutes, we will simulate the exact moment the crust fails, and why this time the warning may come too late. Let's look at the data that has the Icelandic Met Office so concerned. 20 million cubic meters of melted rock.
Whenever there's news about volcanoes or earthquakes globally, you'll hear it here first. Feel free to stick around with a subscription.
Forget Olympic swimming pools. Instead, imagine a cube of liquid fire, almost 300 meters high, wide and deep, pressing against the underside of the Earth. This isn't a new record, it's an overload. Before 2024, the reservoirs were considered full at half this volume. The Svartsengi chamber is overfull, beyond its limits. It's no longer a reservoir, it's a pressure weapon. But what do 20 million cubic meters mean in terms of actual raw power? Scientists calculated the thermal energy in this magma body equals about 500 Hiroshima bombs. Not in explosive force, but in thermal energy waiting to be released. This isn't a campfire, but an underground oven with enough energy to reshape an entire coastline. Picture the Earth's crust as a high-altitude balloon's rubber. You pump in the intended amount of air and it's fine. But now we are at double capacity. The rubber is no longer flexible, shiny, translucent, and stretched taut with tension. Every week, the ground beneath the Blue Lagoon is pushed upwards by several centimeters. This is the uplift happening in time-lapse. Our seismographs register the creaking of the floorboards, thousands of microfractures, as the solid rock literally crumbles under the immense strain. This isn't a recharge, it's progressive structural loss. If that balloon bursts now, the sheer volume of lava will be enough to bury the peninsula's entire infrastructure within just a few hours. And if that seems extreme to you, history offers a stark warning. In 1783, the Laki volcanic system erupted in Iceland. It wasn't an explosion, but an 8-month-long flood of lava and gas. The consequences were apocalyptic. 25% of Icelanders died. The SO2 cloud drifted over Europe. Crops failed in France and England. Tens of thousands died from starvation and poisoned air, even in Egypt. Historians largely believe that the food crisis ignited the French Revolution. That was Iceland's last systemic eruption, and the magma quantity we're seeing today follows the same accumulation pattern.
Where will the rupture happen? The Sundhnúkur crater row is the scar that keeps reopening. Over the last 2 years, Iceland has spent millions on engineering, massive concrete and earth bulwarks designed to tame the flow. But these walls were built for a different enemy. The sheer volume of a surge of 20 million cubic meters means the laws of physics are turning against the engineers. We are now facing an impossible choice, a Sophie's choice for the authorities in Reykjavík. Imagine you are the chief engineer at Svartsengi. You have 20 million cubic meters of fire heading your way. Your barriers can only hold so much. If you focus all your resources on shielding the residential streets of Grindavík, you leave the power plant exposed. But if the plant falls, there is no electricity or heat for the entire region during the dead of winter. If the lava emerges just 300 meters north of the predicted line, it hits the plant with the force of an engineered flood. It is a winner-takes-all scenario where winning only means choosing which part of your civilization you are willing to let burn. The decision has to be made in seconds, but the consequences will last for generations. But here is the most terrifying update, the one that differentiates this comeback from every other eruption. It is a phenomenon we call crustal fatigue. Think back to 2024. Back then, the rock was a fortress. It was thick, solid, and had the sheer strength to hold back the magma for hours, even days. But after unceasing eruptions over the last few years, the Earth has been bent back and forth too many times. The crust is no longer a shield, it is a sieve. It is brittle, fractured, and riddled with ancient scars. This means the magma does not have to fight to reach the surface anymore. It is sliding through pre-existing pathways like water through a cracked pipe. And that has obliterated our warning window. In previous years, we had 4 hours to move families to safety. Today, geologists warn that we are looking at a 30-minute window. 30 minutes from the first major tremor to the first fountain of fire. But what does that actually mean on the ground? Picture this. It is 3 in the morning. The earthquake hits. You wake up disoriented. Your phone buzzes with an emergency alert. You have 30 minutes. You grab your children. You do not pack a bag. You drive, but the roads are already jammed because everyone received the same alert at the same time. The school is closed. The hospital is already evacuating patients. There is no time to check on the elderly neighbor who lives alone. In 30 minutes, the lava is at your front door. That is the reality of a 30-minute window. It is not an evacuation plan. It is a survival lottery. As one lead scientist recently warned, we will not have the luxury of a countdown. The Earth will simply stand up and burn. And the consequences will not stop at Iceland's borders. If this eruption reaches the scale scientists are predicting, the ash cloud alone could disrupt air travel across northern Europe for days, possibly weeks. We saw what happened in 2010, when Eyjafjallajökull grounded more than 100,000 flights and cost the global economy nearly $2 billion. That eruption was a fraction of what we are looking at now. Beyond aviation, a major sulfur dioxide release could affect air quality across Scandinavia, the British Isles, and even Central Europe. Agricultural regions could see crop damage from acid rain, and Iceland itself would face a cascading infrastructure collapse, including power, water, and heating, in the middle of the harshest season of the year. Iceland is no longer standing on a volcano. It is standing on a reloading weapon. All indicators are at the critical limit, including record-breaking magma volumes, extreme uplift, and a crust that has lost its structural integrity. It is no longer a question of if the ground will surrender, but exactly which second the pressure will cross the point of no return. We are monitoring the sensors every hour. As soon as that first fracture opens, as soon as the pressure drops and the gas escapes in a roar, we will be live with full satellite analysis. If you need to understand the physics of what is coming, subscribe now and hit the notification bell. But there is one more detail, and this one is keeping volcanologists up at night. In recent weeks, monitoring stations near Reykjavík have detected a sudden and unexplained warming of the groundwater. Temperatures have risen by several degrees in wells that are over 30 kilometers from Svartsengi. The chemical analysis of these waters shows elevated levels of sulfur dioxide and carbon dioxide, gases that are typically the fingerprint of magma moving through rock. The terrifying question is, has a second magma system awakened beneath a completely different part of Iceland? If the answer is yes, we are not looking at one crisis, we are looking at two. We will be diving into that invisible threat in our very next analysis. What would you choose? Saving the homes of Grindavík or the power plant at Svartsengi? Do you think 30 minutes is enough? Let me know in the comments. I read every single one. Stay safe. Stay vigilant. Until next time.